Thank you, Odessa and Mika, for the introduction. I appreciate it. It's great to be here and have the chance to speak with you. Just whenever the slides come up on the main screen, we'll go back by one. There we are. So I'll leave these links up at the end. This is going to be a very high-level talk. As Odessa mentioned, no equations. Well, maybe just one or two, but I'll try to be restrained. And so if you want to dig deeper, there's a lot of material here, open source software, papers, all manner of things. I'll leave this up at the end. So my central question here is going to be, how do programmers and IT professionals communicate about what their data elements mean? What are the current methods? What are the risks with using those current methods? And what can we do about it? And in case you think this is just a tech geek talk from the title and my introduction, this affects everybody. Not only does it affect everybody because we all use digital devices, but even at the level of, do you ever use a spreadsheet, right? If you use a spreadsheet, you've probably got headers on your columns that are intended to communicate something about what the use of this data is for, what it's supposed to mean, what its constraints are. But the key thing is with that label, you're projecting onto your users a level of intuition and perception that's probably unwarranted. So let's start with words, because words is that's what we have to communicate mostly our data elements, whether it's a database, labels in a database, whether it's a spreadsheet, whether it's a software program where you're labeling a function call or a method. We're using words. And just a few illustrations of what happens when we use words. Well, if we go back a few hundred years, Samuel Johnson was using some very common words. Our guides told us that the horses could not travel all day without rest or meat. Well, I didn't think horses ate meat, but then I looked up what meat used to mean, and it was just sustenance, right? It was a meal. Horses needed to eat something substantial, and they called it meat back then. Or a translation of Euclid's Elements of Geometry, way back in 1570, great increase and furniture of knowledge. I didn't know my chair was knowledge, but back then furniture had the alternate meaning of infrastructure or support. It was also used metaphorically, even for things like mathematics. So words change all the time. They also change, I think, more rapidly in technical communities or in organizations. We all are familiar with sort of business lingo that develops very rapidly. So this is not just about people hundreds of years ago. It's about a process that happens all the time. It happens to us every day. So meat changed, furniture changed. What about different regions of the world? One of my favorite quotes here, I thought it was Winston Churchill, it's probably actually George Bernard Shaw, that talked about Britain and America being two countries separated by a common language. We supposedly both speak English, but you know, they're the common examples of is boot a car part or a shoe. Completely different in these two different countries. Dinner, one's at midday, the other's in the evening. Or if we want to then go a little farther into France, we talk about entrees. Is that your main meal or your appetizer? In France, it's the absolute opposite. So things change over time. Anybody who speaks more than one language, and this is a very international audience, which is wonderful. Almost everybody here seems to speak several languages, usually many more than I do. That you're all familiar with the fact that we can refer to the same thing in completely different ways. Right? Different pronunciation, different orthography, different grammars, different choices about what concepts are lexicalized as individual words. This is just part of life, so it shouldn't be hard to handle the fact that our software systems also have to deal with this, right? If we rely just upon names to communicate intent, what if the programmer that's using our database is from a different country and speaks a different language? Even a different country as close as going from America to Britain. Meanings change. So how do we rely on people's intuitions about words? How do we standardize things as common as a name? I get this problem all the time. I had this problem traveling here, that I go by my middle name. And it's hard to imagine how such a trivial thing causes so much trouble that people always want to take that first initial and put it into the middle for me. And then they'll tell me it doesn't match my passport and I can't enter the country. we should have some standard definitions. We should understand words in context. Context is really important for understanding individual words. If you get it wrong, maybe something blows up. Programming. Okay, this is an equation, or it's one line of code, so hopefully you can forgive me for this, and hopefully there are a few programmers here. So let's say we have a database object. It has a sub-object called allObjects and a function called filter. Right? What does filter mean? Well, in one context, it might mean filter out all of the years that are less than or equal to 2011, or it could mean do this filter so that you give me all objects that have 2011 or greater. It's ambiguous, and yet I've seen a lot of people call things filter in their program. Now, if you're lucky, maybe they've put some comments up somewhere in the file if they had time and somebody wasn't breathing down their neck to deliver the functionality. But these are some big ifs, right? If everything lines up well, if you have people that understand your context, and maybe your context changes over time. Maybe you don't understand your own context. It's embarrassing the number of times I've come back to my own code 5 years later and had no idea what I was doing. Or worse yet, looked at it and said, who was the guy that wrote this? This doesn't make any sense at all. This was a dumb way to do this. Even just as an individual with the same context, just a few years can cause my intuitions about how I've done something in code or how I've named something in code to change completely. How can we possibly deal with this issue? So what are some common solutions today? The most typical one is talk to the developer. I'm working on John's code. He wrote it last year. I don't understand what something means. He was sloppy about his comments, because programmers are usually sloppy about writing good comments. And so I go over to the next cubicle and I say, well, what did you mean here? Are there any constraints that you didn't talk about? Maybe something that's not obvious in the code? How do I use this data element? Well, that works pretty well if you're in an open plan office and there's only one office and you're in a startup and maybe there's 12 people there and everybody comes into the office too. Everybody's reachable. What about if John Smith has left the company? What if you're working in a large multinational corporation and the author was in a completely different office in a completely different country, maybe even speaking a completely different language? How do you deal with that then? What if you can't get a hold of this person? What if they didn't write good comments? This problem happens all the time. And unfortunately, it seems to be, I talk to a lot of people. I make this pitch about how we're doing software development and how we're naming things. And usually the response I get is, oh, yeah, we're fine, right? We don't have that problem. Any time that I've ever consulted for a company that has a database or a software program or spreadsheets that's beyond, say, 100 elements, everybody has this problem. Everybody. There's been no exceptions, right? Because it's impossible not to have this problem, especially over time. Maybe the first 6 months with one developer or 5 developers, but not 5 years on. It always happens. And often also there's the case of, as programmers, our job is to just make things work. And you get rewarded for just making things work. And that also means adopting somebody else's code and adding functionality on top of something and just making it work and not saying, here's a big problem. Right? You need to integrate 2 databases that were developed by completely different entities. And you need them just figure it out and you do something. And hopefully the thing doesn't break until X number of months down the road when you're on a different problem, right? And you've just been rewarded for making it work, as opposed to addressing this deeper issue by doing something that's going to require a very big change in the process of software development. So what do people do? Again, they read the code, they talk to other people, they read the documentation. Well, that one makes me laugh because, so I remember consulting for a very large Fortune 100 company that had a process of labeling all their data and defining it in a central repository. And about 1/10 of the fields were actually had any comments at all, any sort of label. And usually the comments were rather brief. Something like filters according to an equation. That would be a reasonable comment. I've seen a lot of stuff like that. What does that mean? Does it filter in? Does it filter out? And the challenge is that writing definitions is actually a real skill. And the people that are the best at this in a certain context are lexicographers, people that write dictionaries. This is really hard to do. If you were writing a new dictionary, how do you take a word that may have been in use for centuries, figure out how people are using it, and distill that essential meaning down to a short sentence that not only says what the word sense is, but also what it isn't, how it's different from all the similar words that one might confuse it with. That's a really hard skill. I didn't have any training in that as a programmer. I've never heard of anyone who has, and yet that's what we're expected to do. And as a result, people don't do it. And when they try to do it, they don't do it well. So we're hearing about black swans. Maybe you could look at this famous crash of the Mars probe as being a black swan, where there was essentially a misunderstanding of data elements, a really trivial, seemingly trivial misunderstanding. One group was developing based on the metric system, the others on the English system. They tried to calculate the orbits, and the right orbit was, 50 million miles away. And the thing crashed, and that was very expensive, and people were unhappy. Was that a black swan? Well, I would say absolutely not, because where was the metadata? This should be a completely obvious thing. You don't store numbers without units. I hate it when somebody says, oh, the answer is 100. 100 what? Right? 100 meters, 100 pounds, 100 individual people. A number without any units is useless. That's one of the most fundamental pieces of metadata. And here, NASA, right? I used to work at NASA. There's some really smart people at NASA. It's a great place. But along the line, somebody ran into this problem of just not writing down what they really meant, and it really cost a lot of money and a lot of embarrassment. Another problem that people run into is they'll say, okay, we'll solve it with a process. We'll solve this with proper data governance. We'll require that people write definitions, right? It'll be part of maybe your KPIs, your key performance indicators as programmers. That's a really great step, so that then it's clear how you're being rewarded. Are you being rewarded as a programmer just for creating functionality, or is it for the whole ecosystem of software engineering around that functionality? And one of those essential pieces, obviously, is documentation. But if it's always the 10th thing on the list, it never gets done. It's got to be somewhere in there that is a chief responsibility. And so people develop standards, and I use standards sort of very loosely here. There are big formal standards like IEEE or ISO that are going through multi-year processes with lots of international representatives, but there are standards that are created all day long at companies. Standards that are small and local, but are expected to be adhered to in some way. And there is, they'll have some process for defining, say, what do we mean by this data element? What are its constraints? What are its limitations? And if all we have is natural language for creating these definitions, we've already got a problem, because computers can't help us a lot with natural language. With all the advances that are happening in various applications with natural language, one thing that we don't yet have computers doing is really a deep level of understanding, right? If a computer reads a term like age, you and I can all understand what age is, all the contexts in which it might be used. What are some of the limitations for an age, right? If we see age at work, it probably means that maybe it's age of an employee. Okay, well, in the US, person's got to be at least 14 years old to be able to work legally. If age isn't going to be greater than 125, there are all these things that you and I take for granted that our machines actually don't know. And if our machines don't know these things, they're not going to function the way that we want them to function, right? And if we just rely on busy programmers to put in all these constraints from scratch every single time they write some of these fields, we're also not going to get there. Because all of these common sense things, they add up. There's a lot of them, right? And so let's say we try to create a standard with these things. We try to create a standard that has English definitions or any other language that's going to suffer from the same problem. And we want these definitions of the things that we use in our spreadsheet or our database to be consistent with one another. How do we keep them consistent? Well, usually you've got one person in charge that's the architect. And the architect of this standard is responsible for saying, well, everything we've said on this first page is consistent with stuff on the next page, and so on and so on. And for small standards, that's possible. But what if we have a really big standard? I mean, there are standards out there that ISO has that run to thousands of pages. If it's just text, how do we keep that stuff consistent? It's beyond human capacity. You might assign teams of people to work on this standard and keep their area of responsibility consistent. But how do you keep the entire thing consistent with itself? We need automation. And oh, by the way, search and information retrieval is not enough because it's just searching on words. Right? It's not searching on meaning. We don't have a way to do that yet in terms of machine understanding of language. AI's made great advances, but it's not there yet. So here's an attempt to put into context what various people try to do to address this problem. So the first I've talked about is socialization. Have people talk to each other. Developers talk to each other, they work it out. Right? If there's a mismatch, they negotiate and they create some kind of intermediate program that converts one database into another database. And hopefully they don't gloss over too many issues, or hopefully they don't miss understanding some issues that are lurking in the background for exceptions to what they believe their data means. Next level of trust and stability is documentation. At least write it down. Then it's not just word of mouth. There's a record. Probably your odds are getting better. You know, all of these things are good. A lot of people are down in that left-hand corner where it's really totally ad hoc and there's no process at all. In fact, I would say 90% of the companies that I've worked with are in that corner. Right? They are socialization is the only thing that they're doing. They're not even writing it down. So when you start writing it down, great, that's a good thing. Having some kind of process of data governance, having a database of definitions is a really good thing. Having standardization, having some process that you have to go through that's agreed to by the developers in the company. Formalization is where I think good things really have a potential to start to happen. Right? This is where we need to be, I think, at a minimum, of having ways of defining our data that is inspectable by the computer. And one way that we can do that is with mathematical logic. Now, I'm going to try to give a little hint as to what this might look like, but I'm not going to do a bunch of equations, I promise. Okay, well, we can have equations for you later, Odessa. That'd be great. All right. The next thing, beyond just the specification, beyond the formality of the specification, is reuse. So I don't know that we have, how many people in this room are programmers or have been programmers for at least some part of your career? All right, okay, that's great. So at least we got some folks here that you know already that reuse is an essential part of life. For the non-programmers, let me try to put this into a little perspective. Back in the 1950s, you had a machine that filled up a whole room, and the way you programmed it was probably by flipping toggle switches. And you were flipping individual bits. Right? Or if you were a little bit later, I wasn't in that era, and I just barely missed the era of punch cards and paper tape, but it was almost that painful. You didn't have a lot of support. If you wrote a program that delivered some functionality, you probably wrote every single bit of that, maybe other than like the tape drive access or some very basic elements of the operating system. Well, let's fast forward to now. Right? One of the things that I use as the front end for most programs I've ever written is a browser. Now, the Google Chrome is, I think, well in excess of 1 million lines of code. I think it's probably several million lines of code. That's just one little piece. That's what I use for the front end of my code. And then I use an operating system that also has a few million lines of code, maybe a database system, maybe some kind of a web server, right? All of this stuff I'm reusing. And maybe most importantly, if I'm writing in a modern language like Java or Python, where I do most of my work, I'm reusing a lot of very basic code about data and data manipulation. If it's Java, it's the collection classes. Well, Java has a ton of classes. Let me come back to this in a moment. I'll just finish this bit. So once we have logical specification, the biggest thing I think that we have is automation. There are many forms of automation. I'll hint at some of them. And then finally, at the holy grail of where I think that we should be going to in terms of data specification is proof. And that's what my friend and colleague Josef Urban works on, is figuring out how to get computers to give us a real level of trust and assurance, of mathematical certainty that at least we have a path from question to answer, or we don't have a path from lots of data to a contradiction in terms. So for modern programming, we have very expressive languages. We expect all our languages to be what's called Turing complete. We expect them to be able to compute any sort of arbitrary thing or function, right? Even though there's vast variation in what different programming languages do well. There are very many specialized languages, but we expect all of them to be at a mathematical level equally powerful, and almost all of them are nowadays. This is entirely distinct from declarative languages. What you do in a program is to tell the computer what to do. You create a procedure that it has to follow. In a declarative language, you simply say, this is true, and this is true, and something else is true. That's what you do in algebra. A squared plus B squared equals C squared. There's an equation for you, Odessa, your first one. You're not giving a procedure for doing something with A squared plus B squared plus C squared. You're saying that is a fundamental mathematical truth, at least maybe in some context, right? Or if you say something in the integral calculus, right? You're not giving a procedure. There may be a procedure for doing something with that equation, but fundamentally what you're doing in the language of algebra or calculus or number theory are saying true things about the world. And that's fundamentally different from programming languages. And these different languages have different levels of expressiveness. If all you have is algebra, you're going to have a hard time doing calculus, well, except by successive approximation, but let's ignore that for now. In logic, you have similar gradations of logical power. Right? Some of you hopefully had an introduction to logic or some sort of symbolic calculation as opposed to numeric calculation. You might have been introduced to propositional logic at some point. That's high school, awesome. The very few, I didn't have that in high school. I wish I did. I wish everybody did. Maybe you went a little farther and you had predicate calculus, which is a bit more powerful. But, okay, I thought I was on a roll there for a second. But great that there's any exposure to this, right? So logic has these different languages that have different expressive power. It's like if you're just in algebra, you can't do this stuff. You don't have an integral there in your toolbox to work with. And logics are similarly like this. I mentioned about Java having lots of libraries, so it's not just the big frameworks that you reuse, it's also the little things like the collection classes or how to do file access. This is essential. As programmers, there's no way that we could do the kinds of things that we do today without reusing something like 97% of our code. And yet, for data design, we're back in the 1950s. Everybody just writes stuff from scratch for the most part. That is insane. We have to change that. Right, so here's just, I attempted to find some backup for these statistics. There are a number of different studies of how much code is reused. It seems to be around 3 to 5% is genuinely new, depending upon how you calculate it, for any sort of non-trivial sized program. So another thing that it would be great if some people had, how many people remember back to high school geometry where you had to prove things like side angle side? Okay, awesome, great. So proof is really valuable. It gives you an understanding that's irrefutable in mathematics, and you can do the same things in mathematical logic. And although we might have learned in high school how to do this manually, and if some of you went on to more advanced mathematics, you did all sorts of complicated and sophisticated proofs of varying levels of formality, but now machines can do some of this. And so again, this is the stuff that Josef Urban is working on with this group of having machines efficiently be able to prove theorems in mathematics. Well, we don't have to limit ourselves just to mathematics. We can actually use these same techniques to talk about things in the real world, things in our databases, customer relationship management packages, employee management packages, financial packages, just about anything we can think of in programming. It has terms, and we can use these same features, these same tools to create definitions that a machine can actually do something with. So not just do search, not give us just a match in terms of names of one name is kind of like another or one English comment is like another. We can actually have our machines prove for us that we have, say, mathematical equivalence of two things, or a proof of conflict between different definitions, even more valuable, that can head off bugs. So, all right, so I've talked about the problem. Let's talk about some of the good stuff, right? So I think we all have this, we had a little discussion about one of the challenges is we all like to complain, right? We like to say what's wrong. What are we going to do to fix this? Well, I've spent the last 22 years of my life trying to fix this and creating open source software to do so. I've resisted the temptation to give you all a pitch on that software. If you're really interested, let's have some offline discussion. I want to just say there are solutions out there. All of this stuff is open source. I'm a big open source proponent. I may make less money at it this way, but I have the satisfaction of believing fervently, even if it takes another 20 years, I will solve this problem and have a change in software engineering to take advantage of these kinds of techniques. And the best way I think I can do that is by giving it all away. So we have libraries of concepts and definitions, so we get exactly the reuse I'm talking about. We have tools that help you manage this stuff. They act like an integrated development environment like Eclipse or IntelliJ or any one of these other packages that the programmers here may already be familiar with. Theorem provers, the sort of thing that Joseph and his colleagues work on. Lexicons, because lexicons are still important. I don't want to give the impression that language doesn't matter. It matters a lot. It matters a lot when programmers write really beautiful, clear comments that mean I can understand the code just by reading the comment and not having to read every painful line of the code. That's the worst thing when you're just presented with somebody else's code, you're expected to use it, and there's no comments in it whatsoever. And all the variables are named X, Y, and Z, so you have no idea what those mean either. The language that we use is important, but we are clear, at least in the work that I've done, about how to separate language, labels, from semantics or meaning, which we define carefully in mathematical logic. And I also wrote a textbook on this stuff, and there's lots of videos and other good stuff. Another question I often get is, how hard is it to learn this stuff? Mathematical logic, equations, that sounds very scary. I'm not a big math guy myself. In fact, I got into artificial intelligence because at the time I was going through it, you didn't have to do a lot of math. Everything was symbolic. We just wrote Lisp code. It was great, right? And the really smart kids were going into advanced mathematics or some kind of chemical engineering and learning all this really difficult stuff. I learned something else, and it turns out I can't escape it. I'm back doing equations all the time. So it's about the same effort to learn this stuff as a new programming language, if you want to calibrate the effort, right? Because there's a big unknown here, and I think that scares off a lot of people. I start talking about mathematical logic, right, that's scary. But it's no harder than learning Python if you already know Java, or if you know BASIC, learning Fortran, something on that order. It's both learning the language, the syntax, as well as learning the libraries. So what are enabling features for managing volatility, the thesis of the talk? It's really two things. It's having an expressive, computable language so that I can tell the computer something, anything that I would say to a colleague, but put it in a formal language that it can understand for some version of understand, right? That's a longer philosophical discussion. But we want to make sure that our machines have some access to the intuitions, the background, the context that we would all bring to bear on understanding a particular field in a database. And then secondly, a large library of definitions. This is kind of hard to do. It does take time. Programming is hard. It takes a lot of time to do. The only way we survive is through reuse, and we should be taking the same approach for information design instead of writing everything from scratch. So hopefully, you won't have this reaction, but people often do. My gosh, this is impossible. The mountain is too high. I can't climb it. Our organization just can't do it. We can't handle change. And sometimes there are organizational impediments. First, it isn't too hard to learn. I've taught high school students how to do this. I've had groups of summer interns fresh out of high school. In a couple of weeks, I have them writing formal logic using the packages I've created. The tools help, but mainly it's the process. It's just not that hard. To write the hard stuff is hard, right? I'm not writing operating system kernels myself. I consider myself a fairly good programmer, but there are levels to this, right? And so average people can do lots of useful things without being geniuses and working on the super hard stuff that maybe only a few people in the world have to write. This stuff has already been written. I don't have to write an ontology of time and temporal relations anymore. I've got one. If I asked some high school intern to do it, they'd probably struggle. But they don't need to do it. They just reuse it. It's so much easier. And then the second impediment that I often hear about is, well, there's too much change. This is a change in process. And especially at the local level, it's going to be hard for somebody to see that, I had a friend who works at labs, and I asked him exactly this question. Can I get this in? He understands the problem. He says he has this problem every day. He's got a team of 24 programmers, and they're writing the website code for. He says it happens every day that somebody doesn't understand some field or some method that somebody else has created, and the comments aren't good enough. They have to spend time talking to each other and working it out. But then I ask him, well, okay, so you're spending a lot of money doing this. He's like, yep. So what are you going to do about it? Nothing, right? Because his job is to get that project done and out the door, and the next person that has to use the code, well, that's kind of his problem. This is a sad feature of modern business. Right, so maybe you do have that problem, and maybe there's an organizational issue I can't answer for you. But I guarantee that the sunk cost fallacy is applying here across the organization. That if your senior management could understand this problem, or maybe I'm lucky, maybe you are senior management, and hopefully I can introduce you to this issue and you can take action on it. So there are solutions. Even the hardest thing sometimes is possible with the right tools. So that's the positive message I want to leave you with. Thanks for listening, and here are some resources.